So Mr. Satya, naming ionic compounds by Criss Cross method. Okay, Mr. Satya, are we clear about the valencies?
Yes, sir.
Are we clear about what are anions and what are cations?
Yes, sir.
So what are anions, Mr. Satya?
So which have negative charge.
Shabash. What are cations?
So with positive charge.
Shabash. So any simple example of an anion, simple example of a cation that you remember?
So for an ion, it can be chloride.
It can be chloride.
Yes.
Shabash. It is the
Yeah,
simplest.
and cation can be like zinc.
Zinc. Shabash. So you take an ion and you take a cation and then you form a ionic compound because ionic compounds have electrostatic force of attraction between opposite charges. Mr. Satya, are we clear?
Yes, sir.
Basically all this means in simple languages that if you have an ionic compound, the simplest ionic compound that you can take is NaCl. So all that I'm trying to tell you is that in an ionic compound there will be two opposite charged ions which will be attracted to each other. Any doubt?
No doubt.
And whenever you do the nomenclature, there is a word which you will find in chemistry: nomenclature means way of naming compounds. So when you are naming the ionic compounds, the positive species is put first, the negative species is put second. Any doubt?
No, sir.
So for example, when we look at this sheet, in this sheet we'll see all these anions and we'll see all these cations. Now when we will be naming these ionic compounds formed by these anions and cations, we need to remember that the cation will come first and the anion will come second. Mr. Satya, any doubt till here?
No, sir.
And the second simple thing that we need to understand is, let us take this example of MgCl2. So Mg has a valency of 2. I will write that valency without the plus minus sign below magnesium. Then I will take calcium with, I will write its valency without any charge beneath it, and then I will crisscross. The ionic compound would be, the name of the ionic compound would be the valency of chloride, which is 1, the valency of magnesium, which is 2. And like in algebra, we don't write 1x, we don't write 1y, we only write x or we write y. Similarly, when we are naming ionic compounds, we don't write Mg1Cl2, but we write MgCl2. Mr. Satya, any doubt?
No, sir.
Another thing that we need to understand is that whenever, see here, Mr. Satya, pretty simple case because chloride is one element only, magnesium is one element only. The things start getting complicated when you are dealing with a group like this. So for example, the cation is ammonium. Now what you need to understand is that whole of this group has a positive 1 charge. Mr. Satya, any doubt?
No, sir.
And to add to the complication, you have an anion which looks something like this. Now this whole of this anion has a valency of -3. Any doubt? Mr. Satya?
No doubt, sir.
Now when I have to form this compound, again the process remains the same. Take NH4, write its valency below it without the sign. Take the second party is the anion. Take the anion, write its valency below it without the sign. Mr. Satya, any doubt?
No doubt, sir.
Then do a crisscross. What the crisscross means is that you have NH4 here, you have PO4 here. The valency, this valency would be written like this, and this valency would be written something like this. Mr. Satya, any doubt?
No doubt.
And like we have discussed, this can be ignored, so the name of the compound would be NH4 thrice PO4. Mr. Satya, any doubt?
No doubt, sir.
See, Mr. Satya, so for example, this compound that we have made, I'll just brief you. What does this mean? NH4. This NH4 implies that there is a 1 nitrogen and there are 4 hydrogen. Have you understood?
Yes.
What this PO4 implies is that there is 1 phosphorus and there are 4 oxygen. Any doubt?
No doubt.
See, we need to understand this because the compound which gets formed, NH4 3PO4. This compound which gets formed, if you have understood till here, this compound will have 3 nitrogen, 12 hydrogen, 1 phosphorus, and 4 oxygen. Mr. Satya, is it making sense to you or not?
Yes.
No confusion?
No doubt, sir.
Okay. So see, what you need to be very clear is, because this will help you in 9th class also, what you need to be very clear is that this 3, what does this 3 implies? This 3 is like the 3 that we write in algebra like this. Have you understood what I've said?
Yes, sir.
So this 3 will get multiplied with this x, this 3 will get multiplied by this 4, so this 3 will get multiplied by this 1, so there are 3 nitrogen. This 3 will get multiplied by this 4, and that is why there are 12 hydrogen. This 4 is only with oxygen, so that is why we have 4 oxygen, and this below phosphorus there is a 1, so that is why there is 1 phosphorus. So that is clear.
Yes, sir.
So once this is clear, now let us look at these compounds and see if there is any mistake. Yeah. So NaCl is correct. NaNO3. So we are taking Na, we are taking NO3. So NaNO3. Both have valency 1. That is why you have written NaNO3, which is a correct formula. Na2SO4. How do Na2SO4? Na has a valency 1. Sulfate has a valency 2. By Criss Cross method, this would be Na2SO4. Mr. Satya, any doubt?
No doubt, sir.
So Na2CO3, the same logic. NaOH, the same logic. Na3PO4, the same logic. Any doubt till here?
No, sir.
Mr. Satya, see, one thing that you need to understand is, once you have made the compound, just have a look at the compound closely for the valencies. So for example, if I look at this, the first line of compounds that you have made, this makes sense, 1 1. This makes sense, 1 1. This makes sense because sulfate has a valency of 2, which is coming here, and sodium has a valency 1, which is invisible here. Satya, is it making sense?
Yes, sir.
Similarly, the valency of Na is 1, that is why you see a carbonate alone, but the valency of carbonate is 2, and that is why sodium is 2. NaOH, both anion and cation have valency 1, that is why NaOH is making sense. When you look at Na3PO4, Na has a valency of 1, which is invisible here, but the valency of phosphate is 3, which is visible here. So is it making sense or not?
It's making sense.
So what I'm trying to tell you is that, how can you make out whether the compound that you have made is correct or not? So same logic will apply here. So let us check this ZnCl2. So valency of zinc is 2, but valency of chloride is 2. Is it making sense?
Yes, sir.
So that is why when we look at, now let us closely look at the second line only. Yeah. Now we know that valency of Zn is plus 2. So this plus 2 is coming here. Zn plus 2 is coming here. Valency of nitrate is 1. That is why there is an invisible 1 here. Mr. Satya, am I correct?
Yes, sir.
But when you write a compound like this, see Satya, so Zn2SO4 2. Please understand that this 2 and this 2 will cancel, so it has to be written as ZnSO4. Satya, is it making sense?
Yes, sir.
Similarly, when you look at this, valency of zinc is 2, valency of carbonate is 2. When you do crisscross, so this 2 will come here, this 2 will come here, and because 2 is a common factor, that is why the formula will be ZnCO3. So is it making sense?
Yes, sir.
So that is why this should be ZnCO3. Any doubt?
No doubt, sir.
Now again, if you look at this, ZnOH wise, do you think this is correct or incorrect?
Sir, I think it's correct.
I think it is correct. Okay. See, the valency of zinc is 2. The valency of hydroxide is, Mr. Satya?
1.
So when you do crisscross, what will come here and what will come here?
So Zn will be 1 and OH will be 2.
But what you need to understand, Satya, is that this hydroxide is one entity. Is it making sense?
Yes, sir.
See, you need to understand the difference between ZnOH twice and ZnOH2. What this implies is, please try to understand, what this implies is that there are 2 oxygen and there are 2 hydrogen. But what this implies is that there are only 2 hydrogen and there is a single oxygen. Satya, have you understood?
Yes, sir.
So have you understood? So what do you think now? Is this correct or incorrect?
So now it's correct. So this is incorrect, sir.
This is incorrect.
Which I thought is incorrect.
Yes. So it should be written like ZnOH twice. Is it making sense now?
Yes, sir.
See, what you need to understand is that this SO4 is one entity. This is one entity. This is one entity. And this charge is on the full entity. This charge is shared by this. This charge is shared by this. Is it making sense?
Yes, sir.
So what I'm trying to tell you is that when you look at this, okay, when you look at this SO4 minus 2, it doesn't mean that this oxygen has minus 2. What it means is that sulfate as a group has a minus 2 charge. बेटा समझ आया?
Yes, sir.
This minus 2 charge, what you can, maybe this will help you to understand. This minus 2 charge is over whole of sulfate. Is it making sense now?
Yes, sir.
So that is why we are trying to understand this topic with the help of examples, so that there is no confusion. So Zn PO4 twice, is it correct or incorrect, Mr. Satya?
Sir, it's incorrect.
Why is it incorrect?
Oh, no, sorry, sir, it's correct.
It's correct, sir.
Yeah, yeah.
Correct. So you do crisscross, and there is a Zn which will have this valency 3. And please understand that PO4 phosphate would be put in a bracket, and then it will have this 2 written here. So this is the name of the compound. But is it making sense or not?
This is making.
Now, what I want you to understand is, this will be a bit difficult to make sense now, but let us try. So what I'm trying to tell you is that what this implies is that there are 3 zinc. 3 zinc. What this implies is that there are 2 phosphorus. What this implies is that there are 4 into 2, 8 oxygen. Mr. Satya, any doubt?
No, sir.
Okay. So now we come to the third line. So silver cation has a valency of +1. Has a valency of +1. So chloride has a valency of -1. Chloride, let me zoom out. Yeah. 1 second. Yeah. So silver has a valency of +1. Chloride has a -1 valency. So AgCl is correct. Again, Ag1 nitrate 1. So AgNO3 is correct. Ag1 but sulfate 2. So this is correct. Ag1 but carbonate 2. So this is correct. Ag and hydroxide both are 1. So AgOH is correct. Ag has 1 but phosphate has 3. So this is correct. Mr. Satya, any doubt here?
No, sir.
So AgPO4. So Ag has a valency of 1. Phosphate as a group has a valency of 3. I'm not writing the sign. Criss Cross method. So Ag will have this valency 3 transferred to it. PO4 will have this valency transferred to it. The valency of silver, this valency will be shared by the full group, and this one can be ignored. That is why it is written as Ag3PO4 would be the final answer. Mr. Satya, any doubt?
Doubt.
Okay. So NH4 plus 1 ammonium, the group ammonium as a whole has a charge +1. But is it making sense?
Yes, sir.
It is not as if this +1 is the charge shared by nitrogen only, or that +1 is shared by hydrogen only. Please do not think like that. Now, so when NH4 plus 1, so let us try to make the compound. So NH4 has a valency of 1. Chloride has a valency of 1. By Criss Cross method, the formula should be NH4Cl. Mr. Satya, any doubt?
No doubt.
So now when we look at this, the mistake that is done is, 1, the positive NH4 should come first. The negative Cl should come later. Any doubt?
No doubt.
Can you see the mistake? Can you see why it is?
Yeah.
Okay. 1 second, let me zoom. Yeah. So let us look at this line now. So you have understood that this is incorrect. Yeah. So NH4NO3 makes full sense. Why? NH4 is 1, NO3 is 1. By Criss Cross, this is NH4NO3. Absolutely correct. NH4 2SO4. Why NH4 2SO4? Because sulfate as a group has a valency of 2. By Criss Cross, NH4 as a group will get a valency, this valency 2, shared by whole of the group. So NH4 2SO4. So completely correct. This is correct. This is correct. Mr. Satya, is it correct or incorrect? Mr. Satya?
So it's incorrect.
It's incorrect. Why is it incorrect?
So there shouldn't be brackets.
Okay. Any other reason?
So can you zoom out? I can see the valencies.
Can you see the valency now?
Yeah, sir.
So is it correct? Satya, can you see?
Yeah, sir. I can see this one, the left valency, sir.
See, NH4 has a valency of +1. But carbonate has a valency of 2. So when I do crisscross NH4 1, carbonate
Yes,
has
it's
a
correct.
valency of 2. अरे कैसे करेक्ट है भाई? आप crisscross
No,
करो.
sir. Yeah, sir. That's what I'm saying. NH4 too.
NH4 पूरा ब्रैकेट में डाल के उसको ट्वाइस कीजिए. बात समझ आई?
Yeah.
गलती
Yes,
मत
sir.
कीजिए. आप see as a first step you can write it like this. Absolutely no problem. And then you can say that my final answer is NH4 CO3. Is it making sense now? This is my final
Yes, sir.
answer. Is this correct or incorrect?
So there's only one mistake. It shouldn't be in brackets.
Shabash,
The rest it's
shabash,
correct.
shabash, shabash. So there is only one mistake, that this bracket is not required. See the logic, Satya, again and again we are borrowing the logic from maths, where 1x plus 1y plus 1z. This is not how it is written. It is written as x plus y plus z. Satya, do you agree or not?
Yes, sir.
See, what I'm trying to tell you is that the logic is being, if you understand algebra, then you will understand chemistry. So, for example, at least this part of the chemistry. So, for example, when we write xy square cube, have you understood?
Yes, sir.
This cube, this 3, is shared by this x also and this 2 also. Is it making sense?
Yes, sir.
So, this can be written as x cube and y3 into 2, 6. Do you remember this part or not?
Yes, I remember.
Or if this gets complicated, then the easier way is 3 into x plus 2y. Now this, I think this would be easier to understand. This is written as 3x plus 6y. Is it making sense?
Yes, sir.
So this is less of chemistry and more of maths. Yeah? So in this compound, we don't require the bracket. NH4OH is all that we require. NH4 3PO4. Is it incorrect or correct?
So it's correct.
It's correct. Absolutely correct. NH4 3 times PO4. Okay, so try. How many nitrogen are there? How many hydrogen are there? How many phosphorus are there? And how many oxygen are there? Can you try?
Yeah.
Is it making sense?
Yes, sir.
See, 1 into 3 is 3, 4 into 3 is 12. This is 1 and this is 4. Is it making sense or not?
Yes, sir.
It's a bit difficult, so that is not an issue, but you will require this in class 9th. That is why I just want you to be open to this concept. Okay, so calcium has a valency of +2. So Ca plus 2 is what we are. Okay, with Cl we understand has a valency of -1. Has a valency of -1. So my first compound would be CaCl2, correct? CaNO3, correct? CaSO4. Mr. Satya, is it correct or incorrect?
Sir, only there shouldn't be the brackets. That's the
There
thing.
shouldn't be a bracket. Shabash. There shouldn't be a bracket. Why? Because it's a common factor. So the compound would be CaSO4. Absolutely correct, Mr. Satya. This one, is it correct or incorrect?
No, sir. There shouldn't be brackets again.
Shabash. There shouldn't be a there shouldn't be a bracket. Absolutely correct. Why there shouldn't be a bracket? Because this common 2 will cancel. And the compound can be written as COCO3. We don't require a bracket, and therefore my final answer would be CaCO3. Correct. CaOH twice. Is it correct or incorrect?
So there should be brackets only.
Yes, there should be a correct. There should be a bracket, but where should be the bracket?
Sir, OH. Like
Shabash.
it should be in bracket.
Shabash. So Ca has a valency 2, hydroxide has a valency 1 by Criss Cross method. This is 1, whole of hydroxide will share this 2, and therefore this is written as CaOH twice. This can be ignored. Great. Okay. Is this correct or incorrect? Mr. Satya.
Sir, it's correct.
It's correct.
Yeah.
Ca has a valency of 2, phosphate has a valency of 3. We do crisscross. This would be Ca3, PO4 whole twice. So this is the correct formula. Great. Now, in bracket, they have written Fe plus 2. What does this imply, Mr. Satya?
So the 2 is meant by its valency.
Shabash.
So its ions valency is 2.
Shabash. Shabash. So when the metals have variable valency, so for example, you can have Fe1. Here, what it implies is that iron has a valency of plus 1. Mr. Satya, is it making sense?
Yes, sir.
So when usually, as we have discussed before, transition metals have variable valencies. So that variable valency, that which is the valency with which we should form the compound, that is written here in the brackets. So FeCl2, correct. FeNO3 twice, correct. FeSO4, correct or incorrect, Mr. Satya?
So there shouldn't be the brackets.
There shouldn't be a bracket. So this is the only small thing that you need to take care. There shouldn't be a, in the final answer, there shouldn't be a bracket. So this has to be written as FeSO4. Is this correct or incorrect?
So there shouldn't be the brackets.
Shabash. So this should be FeCO3. Shabash. Is this correct or incorrect?
So OH should be in brackets.
Shabash. OH should be in brackets. Is this correct or incorrect?
So it's correct.
Absolutely correct. Great. And then potassium. Potassium has a valency of plus 1. A chloride has a valency of minus 1. Therefore, this is correct. This is correct. This is correct. Is this correct, Mr. Satya?
So, yeah, yes.
Yeah. Is this correct?
Yeah.
Okay. Is this correct?
Yes, sir.
Why is this correct?
Sir, no, sir. K3PO4.
K3PO4. Shabash. Very nice. Because what we need to understand is K has a valency 1, phosphate has a valency 3. Shabash. So when I do crisscross, so this would be, this 3 will come here. And this 1 will be shared by whole of this group. So my final answer would be K3PO4. Mr. Satya, is it making sense?
Yes, sir.
Great, sir. So Mr. Satya, I think what we'll do is, rest of these let us discuss in the next lecture. Is it okay?
Yes, sir.
Okay, let us discuss this on Monday. Yeah?
Okay, sir.
Okay, sir. Okay.